beginning Chapter 3 of Calculus, Section 1, Derivatives, the shortcut. I'm your host, Dr. D. Okay, let's get started here. Alright, we've been laboring with derivatives, doing the limit as h approaches 0 of f of x plus h minus f of x all over h, and having these huge long things to do. And it turns out it's actually pretty simple. We have this thing called the power rule now. The power rule basically says that if you have a function x to some power, then the derivative of that function is n times x to the n minus 1. Or another way of writing the same thing, the derivative of x to the n is nx to the n minus 1. What's that mean? Well, that means you take the power and you put it down in front of the variable, and then you drop the power by 1. Simple. Okay, so watch. If we have y equals a constant, what's the derivative of that? Well, notice the constant, let's back up a step. Y really equals a constant times x to the 0. Alright, so what we do is we bring our 0 down in front, so it's 0 times c, which is 0, and then it's 0, that's it, we don't care what it is. So we end up with dy dx equals 0. Now, what sort of madness is this? Well, if y is a constant, what kind of line is that? Right, it's just a horizontal line. What's the slope of a horizontal line? 0. That's it. Piece of cake. It's more fun than a barrel of monkeys. Okay. Now, what if we have y equals x? Then what's dy dx? Well, this is really x to the first. So I take my 1 down in front, and then I drop my exponent by 1. So dy dx equals 1 times x to the 0. And x to the 0 is 1. So the derivative of y equals x is 1. Think about that now. What's the slope of the line y equals x? It's 1. See, that's the thing. The derivative is simply the slope of whatever function we have. Okay, let's take y equals 3x now. What's the derivative of that? Take our 1 as the exponent, multiply it by 3, and then drop the exponent by 1, so it's going to be 3 times x to the 0, which is 3. And we know the slope of the line y equals 3x is 3 everywhere. All right, now, what about y equals negative 2x plus 1? Well, remember, we found out that the derivative of a constant is 0. So the derivative of 1 is just 0. So what's the derivative of negative 2x? Well, you take your 1, multiply it by negative 2, and then drop the exponent by 1. So this ends up equaling negative 2 plus 0. And the line y equals negative 2x plus 1, the slope is negative 2. Okay, so we've been dealing with the derivatives of straight lines, which is really simple. Those derivatives will always equal some constant. Now, the derivative of a curve, y equals x squared. Well, what do we do with that? We bring our 2 down in front, and then drop the exponent by 1. So 2x to the first. So the derivative of y equals x squared is 2x. And notice we've been talking about this for a while now. If I have y equals x squared, it's looking like that. Now at the point 1, 1, then my slope is 2 times 1, which is 2. So the slope here at 1, 1 is 2. Now if I go x equals 2, then I'm up here, my slope is 4. So basically this shows that with different x values, you have different slopes. And that's going to be the way it is with any curve. All right, now we're going to go hog wild. Now basically, this is showing you that if you have a polynomial, you can take the derivative of each thing as you go, and then just add them all up. And those properties are in the book, and there are proofs in the book. For that matter, there are a couple of proofs in the book for the power rule in general, and you should take a look at them, although I'd rather not go over them here because they're right in the book. All right, so if I have 5x cubed, what's the derivative of 5x cubed? It's 3 times 5x squared. So that becomes 15x squared. What's the derivative of minus 3x squared? It's going to be 6x to the first. Minus 6x. And what's the derivative of 2x? 2. What's the derivative of minus 7? 0. Now notice one more thing. We've talked about this before too. The derivative is always going to be 1 degree less than the original function. Remember when we were graphing functions and their derivatives, the derivative is always 1 degree less. Well, if I have a constant, which is degree 0, then my derivative is 0. If I have y equals x, which is degree 1, then my derivative is a constant. Notice 3x degree 1, derivative is a constant, degree 0. Now, if I have a second degree function, then my derivative is first degree. If I have a third degree function, my derivative is second degree. Always 1 less than the original function. Okay, cruising onward. All right, we're going to crank up the juice just a bit here. What about if f of x is 1 over x? What is the derivative of that? So what I want is f prime of x. Now notice I'm showing you two different notations here. Here I'm saying y equals something, and now we're going dy dx. And now we're going f of x equals something, now we're going f prime of x. I want you to know both notations. All right, so how do you take the derivative of 1 over x? Now, at this point, if you can figure out how to do all these, you could pause the video right now, do all your derivatives, and come back, check it, make sure you got it right. Okay. If f of x is 1 over x, then basically that means f of x equals x to the negative 1. So that means the derivative, f prime of x, is going to be negative 1x to the negative 2. Bring your negative 1 down in front and then drop the exponent by 1. So what's that equal? That equals negative 1 over x squared. All right, now, if f of x equals the square root of x, what's f prime now? Well, let's make this an exponent, so we'll make it x to the 1/2 power. And so now f prime of x is going to be 1/2 x to the negative 1/2 power. We're dropping the exponent by 1. So what do we end up with? It's 1 over 2 square root of x. Notice the negative 1/2 power is the square root of x on the bottom, and the 2 stays on the bottom, so that's it. All right, what about the 5th root of x squared? The 5th root of x squared, how do we do that? All right, all we do is change this to a fraction. So this equals, yes, thank you, x to the 2/5 power. So that means f prime of x is going to equal 2/5 x to the negative 3/5. Notice we just take our exponent down in front and then drop it by 1. So 2/5 minus 5/5 is negative 3/5. And then when we simplify that, this is going to equal 2 over 5. Now notice it's the 5th root of x cubed. And if we rationalize that, we could multiply by the 5th root of x squared over the 5th root of x squared. And notice now we have 5 x's to spring the pokey. And now we end up with 2 times the 5th root of x squared all over 5x. Now, really, 2/5 x to the negative 3/5 is simpler than 2 times 5th root of x squared all over 5x. So this is actually a simpler solution. But if you're asked for it in radical form and you want to rationalize the denominator, then that's going to be it. Okay, let's do another one. What about 1 over the cube root of x? All right, so that equals x to the negative 1/3. Okay, so what's my derivative then? F prime of x is going to equal negative 1/3 x to the negative 4/3. And once again, so notice, bring the exponent down, drop it by 1. And like I said, we can turn this into radical form. So this is going to be negative 1 over the cube root of x to the 4th. And yeah, what the heck, we might as well finish it up. So we're going to make this, the x cubed can spring the pokey. So we've got an x outside, so we have negative 1 over x times cube root of x. And notice, in order to spring the pokey, we're going to have to multiply by the cube root of x squared over the cube root of x squared. Now we have 3 x's, we can spring the pokey, and so this ends up being negative cube root of x squared over x times x, which is x squared. Oh, I just forgot the 3. I knew something had gone awry. Okay, so there's a 3 here because it's negative 1/3 times the cube root of x to the 4th. All right, and so then we put a 3 here and a 3 here. So like I said before, this is actually a simpler form than this beast. All right, and one last time, 5 over 2x squared is our function. What is our derivative? Well, remember, we're going to change this to 5/2 x to the negative 2. All right, now when I take the derivative, f prime of x is going to equal 5/2 times negative 2, which is negative 5, x to the negative 3, which will equal negative 5 over x cubed. Did I do that right? Let's see. Yeah, 5/2 x to the negative 2, so negative 2 times that is negative 5 x to the negative 3. Yeah, that's right. Yeah, it's just kind of strange. It worked out really nice and neat. So this is our final answer. All right, so you guys now see the power rule. If f of x equals x to some power, you take that power down in front and then drop the exponent by 1. Piece of cake. Now, like all things in calculus, we learn the hard way and then all of a sudden we find out there's an easy way. But then we find out that since we know an easier way, now we can complicate things some more. So be ready for that. Be ready for complication. Yes. Okay. Last thing. Okay, here's the question. At what point on the curve y equals e to the x is the tangent parallel to y equals 2x? All right, so here's the curve y equals e to the x in purple. And here's the tangent to that curve in red that's parallel to the line y equals 2x. All right, now, this is in the book, but what I'd like you guys to do, once again, turn the video off, work this out, see if you can get it, and then turn the video back on, see if you did it right. Okay, go ahead and turn the video off now. I know you didn't turn the video off. Do it for real this time. All right, okay. So, notice what we're asking here. The slope of the tangent, oh, you know, it just occurred to me. I never did tell you what the slope of y equals e to the x is. We forgot something. Okay, we'll edit that out. Okay, here's a simple piece of information that you need before you can do this. The derivative of e to the x is e to the x. That's a necessary thing. Now this is a pretty strange thing when you think about it, because what you want to do is say, okay, let's bring the x down in front and then drop it by 1, so it'd be x e to the x minus 1. That is totally not the way it works. Because notice the power rule is the derivative of x to the n. So that's the derivative of a variable to a constant. Variable, base, constant, exponent. Well, e to the x is not a variable base. It's a constant base. E is a constant. And the exponent is not a constant. It's a variable, x. So the derivative of e to the x is e to the x. It's almost like magic. So now we can go back to that problem that I just told you about. All right, now we have the curve y equals e to the x. I want to know at what point on this curve will the tangent be parallel to y equals 2x. Okay, now we need the tangent to have a slope of 2. What does that mean? Well, that means we take the derivative of our y to the e to the x curve and set it equal to 2. So, I've got dy dx equals e to the x, which equals 2. See, notice dy dx is the slope of the e to the x function at any point x. So now what I need to do is solve for x with e to the x equals 2. How do I find out the x value where e to the x equals 2? Right, I take the natural log of both sides. So I say then that x equals natural log 2. Now if x equals natural log 2, then what does y equal? Well, if I know that y equals e to the x, then that means y equals e to the natural log 2. Then that means y equals 2. So what that just told me is this point right here, the x value is natural log 2, and the y value is 2. That's my tangent point. Good thing we can see that the y value is 2, the x value is natural log 2, which is about 0.7 something. Okay, so there's our point. At what point on the curve is the tangent parallel to y equals 2x? So all we did was we said the tangent is going to have a slope of e to the x at any point. So all I need to do is find out what x value gives me a slope of 2, because y equals 2x has a slope of 2. And that point is x equals natural log 2, which will then give me the point, or the y value 2. Now, what if we were asked for the equation of our tangent line? Somehow we got this equation because it's already been graphed. Okay, so how do we get the equation of the tangent? Well, it's just y minus the y value equals m times x minus the x value. All right, so it's y minus the y value. What's the y value? 2. Equals m. What's the slope? The slope is 2 times x minus the x value. What's the x value? Natural log 2. There's your equation. Now, if I want it in slope-intercept form, then I can go y equals 2x minus 2 natural log 2 plus 2. And I could factor a 2 out of that whole thing to make it a little cleaner. So it becomes 2 times x minus natural log 2 plus 1. And that's it. That shows me the equation of this red line because it's tangent to the curve. So, it's as simple as it gets. This is probably one of the easier lessons that you're going to have in calculus all year. So, really, have fun with these.